Hey. So in this video, what we're focusing on now is more so how to match equations to a scenario. And in some of them, we might have to write our own. Like for example, in numbers 1 and 2, there are no equations for us to match. So for 1 and 2, we're certainly going to have to try to write these things out. And then you can see for a problem like number 3, that's where we might have to match one of these equations to the scenario. So that's what we mean by trying to write our equations or match the equations to the scenarios, all right? So we're going to dive on in here with number 1. A fitness center charges $2 per visit, or like $2 per class, and a $10 monthly fee. Now, the monthly fee might go towards things like electricity, having to pay for the employees to work there, things like that. And the $2 per class just might mean like the more you use a certain part of the gym, the more you're going to have to pay. So last month, Keisha's gym bill payment was $34. So in a month, it looks like Keisha spent $34, and we know 10 of that was just the monthly fee. So how many times did Keisha go to the workout at the gym last month? So if we want to know how many times did she actually go to the gym and it's $2 per visit, here's going to be our equation, okay guys? Per usually means like each, so this is going to be like a $2 per visit each time she goes, and then $10 in a monthly fee no matter what, and that is how she spent $34 in a month. So this is the equation that we're going to use right here. 2 times the number of visits plus the $10 monthly fee, and her total bill was $34. Now what we want to know is how many times did Keisha go work out at the gym last month? So basically we just need to solve this equation. Now when we take this, I'm just going to actually move everything down here so I can write the equation up top. Here we go. So if this is our equation and we now go to solve it, when we solve it, the entire point here, y'all, is like, okay, let's take away the $10 of the monthly fee. If 10 of the dollars were for the monthly fee, that means we know she spent $24 on her visits. So if we divide that by $2 per visit, we can see now that she must have gone 12 times. So 12 times she went, 12 times. Okay? So we wrote the equation for the scenario, and then we were able to solve it to answer this question. All right, now for the next one. Emily's grandfather at 73 years of age is 5 years more than 4 times old as Martha. What is Martha's age? All right, so Emily's grandfather right now, he is 73. Okay? And that is 5 years more than 4 times old as Martha. So you might remember, we already know that we've got the 73 is, that part is translated. Now 5 years more than, we have a than. So 4 times as old as Martha, we're going to have 4 times as old as Martha with a 4m. Now show me 5 more than that. So we have now translated that Emily's grandfather at 73 is 5 years more than 4 times Martha. So if we want to know Martha's age, we just simply need to solve for m. So let's get rid of those 5 years more. All right, and that right here puts us at 68. Now this is 4 times Martha, so we're going to divide by 4, divide by 4. And when we do this right here, the 68 divided by 4 is 17. So we now know that Martha is 17, which is answer choice B. You will see a question like this later on for Horizon. So I just want to point out that again, 5 years more than 4 times Martha. The 5 years more than 4 times Martha is right here, and that was set equal to the 73. Okay? If we want to check our work, we can basically say, let's do 4 times Martha's age. So 4 times 17. Let me get my calculator out. Don't have it right there. Here we go. So if we do Martha is 17 and we say 4 times that, now 5 more years, that's Emily's grandfather's age, 73. All right. If Rick bought a laptop for $1,900 and made a down payment of $400, what that means, y'all, a down payment right here, it's when you're in a store and it's what you go ahead and pay right then and there, and then you have to pay the rest over monthly payments. So if you're in a store, again, whoops, that's a flat fee. If you're in a store and you make a down payment, you're basically paying it right then and there, and then the rest of it you somehow pay in equal payments. It looks like here for Rick, if the laptop is $1,900, let's go ahead and put 1,900 equals, and 400 of it he's going to go ahead and pay in the store. That's the down payment, plus now the 5 equal payments. We don't know how much each payment is going to be, but he's going to make 5 of them. And plus the $400 that he paid in the store will pay for the $1,900 laptop. So we just translated it, and now we just need to match down here which equation it is. So we're looking for the equals 1,900. This one, B is out because it doesn't say equals 1,900. A is out because it says 400 per payment. That's weird. No. All right, now C is out because it's not showing again the total cost of the computer. The laptop is $1,900. This one right here shows that the laptop is $1,900, and the way you pay for it is the 5 equal payments plus the $400 in the store, the down payment right there. Okay. If we wanted to take it a step further to find out how much each payment would be, we would subtract the 400. So 400 you paid in the store, so that means now you would owe 1,500. And if you divided that by 5 equal payments, each payment would be $300. So we could go on to solve it and learn that each payment would be $300. It's not asking us to do that in the problem, but I wanted you guys to show that in case you see another one like it later on. All right, Ian and his friends go bowling over winter break. Now the bowling alley charges $3 to rent bowling shoes, and then it's $5.50 per hour of bowling. So you got to pay the $3 no matter what to rent the shoes, and then it's $5.50 for each hour that you bowl. Okay. Now we want to know how much is Ian going to be charged if he bowls for 3 hours. Now this problem is in here on purpose. We don't have an is. There is no equal sign. It doesn't tell us how much Ian spent already and then wants us to work backwards for the number of hours. It's not like that. This one is back to kind of being a Unit 3 problem, and I'll put it off to the side, where we're going to plug in and we're going to evaluate after we replace this variable. We're going to replace this variable h here for 3 hours. All right. So anytime we have a variable and we plug it in, we can use PEMDAS now to simplify, and I'm just going to erase. Well, actually, I can rewrite it. I should rewrite it. So we're saying it's $3 to rent the shoes plus $5.50 per hour for 3 hours. Now the $5.50 times 3, let's see how much that's going to be for the 3 hours. Cool. So $16.50 plus the $3 to rent the shoes. So this is going to be $19.50. So you can use your skills of translating to translate an expression to then plug in and simplify. So I just wanted you guys to see that this skill can be used to translate expressions like we did back in Unit 3, and then we had to plug in and evaluate using PEMDAS. All right, number 5 and 6 are back to matching the equations. You can see we have scenarios, and then down here we're going to have some equations to match. So for number 5, we have that a car rental agency charges $50 per day and then $3.50 for each mile driven. So $50 per day and $3.50 for each mile. Now Catherine paid $190 total for renting a car for them for 1 day. So if it's $50 per day and she only rented it for 1 day, we should only see a plus 50. Okay. Now it is $3.50 for each mile, so we're going to put a 3.50 for each mile, so $3.50 times M plus the $50 to rent it for the day, and we can see that that is equal to the $190 that Catherine paid them. So which of the following equations could be used to find the number of miles, which would be M right here? All right, let's just match it up. We're looking for a 350M, which this one has and this one has. This one doesn't have it, but this one does. Now we're looking for the 350M plus 50, so you're out, Here is the, whoops, this one was already out, JK. Here is the $3.50 per mile plus the $50 per day for that one day equals the $190 that Catherine spent. So this one is the one that matches up with the scenario. We would, to solve it, to find the number of miles, we would subtract the $50 minus the 50 for the day, and then we would do the 140 divided by that to see how many miles she drove. All right, for number 6, Tom bought an iPad for $800, so we should be seeing an equals 800. We do not see equals 800 for B. We do see it for C. We do not see it for D. So I do see it here for A, it equals 800. Equals 800. All right, he made a down payment of 200, so again, the total is going to be the 200 that you paid in the store, the down payment. And then he's going to pay the rest in 6 equal payments. So answer choice C, this is the one we're looking for. It shows it's the 6 equal payments plus the $200 down payment is the 800 total for the iPad. All right, for number 7, a taxi company charges a $3 flat fee in addition to $1.25 per mile driven. Which equation models this scenario? So the $3 flat fee, y'all, the flat fee is the constant because you have to pay it no matter what. Okay, the flat fee is a constant because you have to pay it no matter what. So we're looking for the plus 3. You have to pay that no matter what when you get into most cabs. And then it's $1.25 per mile. And that gives us the total cost. So for this one, it's going to be answer choice D. This shows us that it's $1.25 per mile plus the $3 flat fee no matter what. Okay? All right, and number 8 now. So this one's kind of like the one up here with Emily's grandfather, the age question. Here's another age question. Let's see how we're doing with the age stuff, okay? So Andrew is, so we've got that Andrew here, is 3 years younger than 1/4 of his brother's age. So 3 years younger than 1/4 of his brother's age. So we've got 1/4 of his brother's age. Now show me 3 years younger than that by minusing 3. If Andrew is only 2, so Andrew, we can erase here now. Whoops, sorry, there's the eraser. We know A is Andrew, and we know that he's 2. So Andrew, being 2 years old, is 3 years less than 1/4 of his brother's age. So we're looking for equals 2, equals 2. I don't see equals 2, but I see it here. And now we're looking for 1/4 of B minus 3. So here's 1/4 of B minus 3. So it's got to be answer choice A. If Andrew is 3 years younger than 1/4 of his brother's age, that's translated, and we know that Andrew is 2. So his age of being 2 is 3 years younger than 1/4 of his brother's age. That concludes this video on how to match or write, in some cases, our equations for the scenarios. Thank you for watching this video.